This is the AP Stats Chapter 2, Lesson 1 outline. We looked at ways to describe distributions, shape, outliers, center, and spread. Now we're going to jump into looking at how do we compare a value to other values from the same distribution. So that's what we mean by relative to its distribution. One way in which we can do that are percentiles. So you've seen these before on test scores, for example, or when you go to the doctor and you hear about your growth, about your weight, and about your height. Percentiles describe the percent of all values that are less than a specific value. So it's what percent of the values are less. So if 7 values out of 10 were less than you, you're in the 70th percentile. If you test in the 90th percentile, you've done better than 90% of other test takers. Now, one key thing to think about that is remember that means quartile 1 corresponds to the 25th percentile. The median is our 50th percentile, and quartile 3 is the 75th percentile. So we can graph these percentiles with our x values being on the x-axis, our values of interest, and then the cumulative relative frequency, which is another way to say the percentile. So when you see cumulative relative frequency here, think percentile, on the y-axis. So obviously it's a graph that has to go either no slope or a positive slope, because you can't at some point have less values than a previous. So it's always going to either be flat, which means there's no values in an interval. The steeper the slope, the greater the amount of values. We'll look at that in a picture in just a second. So it's going to lead up to 100% or one whole, and each point you'd go from the x-axis, go up to the cumulative relative frequency, then over to the left to see its percentile. So here we have eruptions for Old Faithful that vary from about 1.5 minutes, maybe a little more than that, to a little over 5 minutes, maybe close to 5.5 for our maximums. You can see where our minimum is at the 0th percentile. That'd be the minimum. And up close to 100%, that'd be our maximum value. So if I wanted to know what percentile a duration of an eruption of 4 minutes was, I'd go straight up from 4, find the point here, and look over to the left and say that that's about the 50th percentile. That makes that 4 our median. Where I have a steep slope, as right here between 4 and about 4.5, that means a large percent of values lie here. I could say 50% to what looks like about 75%, so a quarter of my values lie right there. If I have a flat slope, that means I have very few values there. The percentile doesn't increase by much in that duration. So we'll have our percentile on the y-axis, the values from our data set on the x. Another way to measure position in a data set is a z-score, or a standardized test statistic, we could call it. So a z-score describes how far a value is from the mean in terms of standard deviation. So we find the difference from the mean, how far it is, and then we divide by the standard deviation. So a z-score of 1 would be 1 standard deviation above the mean. A z-score of -2 would be 2 standard deviations below the mean. A z-score of -1.5 would be 1.5 standard deviations below the mean. So the negative or positive sign tells us negative below the mean, positive above, since we're subtracting the mean from it first. And then the number itself tells us how many standard deviations something is above or below. So it's telling us the location in terms of the standard deviation of the data set. Now this works really well for symmetric distributions because we saw before that when we have symmetry, the mean and standard deviation give us a good idea of the center and spread. With a skewed distribution, z-scores aren't as reliable because we have skew, which affects both the mean and the standard deviation, since the standard deviation is calculated using the mean. So we have some instructions on how to do it. You're subtracting the value x from the mean. Remember, that's the mean of the data set that x came from. And this is the standard deviation that x came from. So it's good to know that this is our symbol we use for the mean, mu. That's the true population mean. And the standard deviation, sigma, is here. So if a student had a 93 on a test that had a mean test score of 80 and a standard deviation of 6.07, 93 is our value of interest. We subtract it from 80, that's 13. We divide by 6.07, and we find that the z-score for that student is 2.14, or 2.14 standard deviations above the mean. So here's what we have in terms of z-scores. So here we have our mean. That would be a z-score of 0, because anything minus itself, like an 80 on this test, would have been a 0. 1 standard deviation above the mean, 2 standard deviations above the mean, 3 above the mean. This is a very specific type of shape called a normal distribution that we'll go into in much more detail in the next lesson, in which we'll use throughout the year. Because of its symmetry from the mean and standard deviation, we can tell a lot about the percentiles and about the likelihood of values occurring. So you can see in this distribution, values above 3, that's a z-score of 3, meaning the mean plus 3 standard deviations. Values above that are rare, and values below a z-score of negative 3, so down here we have minus 1 standard deviations, that's a z-score of negative 1. Minus 2 standard deviations, or 2 standard deviations below the mean is a z-score of negative 2, and a z-score of negative 3 here. And we'll get into this rule about the percent of data that lies within 1 standard deviation, 2, and 3 of the mean. So here is your multiple choice question. The z-score for a value of 70 that comes from a distribution with a mean of 84.3 and a standard deviation of 8.2. Find the z-score and then describe what it means being standard deviations above or below the mean. You may want to look back in the formula we just used. You'll be given that formula on your formula sheet. So pause now, answer your multiple choice, and then push play. One other key concept we have in Chapter 2, Lesson 1 is transforming data. And we're going to look at 2 types of transformations. One by adding a constant. We could think about that as, so A, for subtraction just consider it to be negative. So addition and subtraction have the same rules. So adding A, think about your whole distribution moving to the right for a positive number, or the whole distribution moving to the left for a negative number. So when you add a number to a whole distribution, the center moves by that number as well. So mean and median move up. The quartiles and percentiles, those values would increase by that much. So if I had a mean of 5 and I added 2 to the whole distribution, my new mean would be 7. If my median in that case had been 4.3, my new median when I added 2 to the whole distribution is 6.3. Now, because it moves though, it doesn't change the shape of the distribution or measures of spread. So the distribution, the maximum and the minimum are just as far away from each other. You added 2 to Q3 and 2 to Q1, so the IQR stays the same. The standard deviation is the same because they're still, you added to the mean and all the values got added. So adding or subtracting changes measures of center and location. Does not change the shape of the distribution or measures of spread. Multiplying, on the other hand, when you think about multiplying, if I multiplied a whole distribution by 3, and let's say my maximum had been, the maximum of my data set was 7, and the minimum was 2, I had a range of 5. 7 minus 2 is 5. If I multiply everything by 3, now my biggest number is 3 times 7, 21, and my smallest is 3 times 2, 6. 21 minus 6 is 15. So what happened there? Well, the spread, the range got multiplied by 3 as well. So when we multiply, we also multiply the spread, which is the range, IQR, standard deviation, by the absolute value of that number. If we're dividing, just think about it, dividing by a number bigger than 1, then you're just shrinking it. So the same thing happens. So when you multiply or divide by a constant, you're multiplying or dividing by measures of center and location. So if my mean was 2 before my mean and I multiplied by 3, my mean is now 6. Quartile is the same thing. However, the shape does not change. The overall shape is the same. It just gets more spread out for multiplying by a number over 1 or less spread out for multiplying by a number less than 1. So these are important rules to know. And for this reason, what we can do is if we transform data somehow, we don't have to go back and recalculate all these things. We already have the mean and median, we already have the IQR and standard deviation of the original data set. We can use these rules to calculate the new data set. So when we look at z-scores, we're really doing 2 transformations to our data set. One, we're subtracting. So we're subtracting the mean. So if we turn a whole distribution into z-scores, we subtract the mean from every value. And then we divide by the standard deviation. So subtracting changes the measures of center. So my new mean will be 0 because I'm subtracting the mean from everything. So z-scores will always center around 0 for that reason, because the mean is 0 standard deviations away from itself. Dividing, however, subtracting does not change the shape or the spread. Dividing by standard deviation will not change the shape, so our shape will stay the same as the original distribution. However, dividing by the standard deviation will create a spread of 1 because the standard deviation divided by itself is equal to 1. So when we apply that rule to z-scores for that reason, if you look at the distribution of z-scores for an entire distribution, it will always be centered around 0 as the mean with a standard deviation of 1. So whenever we're graphing data and looking to get percentiles or anything like or z-scores, a nice sketch is good. Even if it's a rough sketch, we're going to use that a lot in class just to get an idea. Should I get a positive z-score here? Is it to the right of the mean? Is it to the left of the mean? Should I get a negative z-score? So you can really quickly tell if you made a mistake. We look for the overall pattern. So we've done A and B in chapter 1 here. We've also done C, numerical summary. And then we look at trying to make find z-scores or percentiles to describe location. If we have a large number of observations and enough, we can sometimes describe it with a density curve, which is where we just chopped off the corners of that histogram to make it a smooth curve. So here we have a density curve. You can see it's just a curve here. It looks very similar to the histogram. They're always above the horizontal axis. The total area underneath equals 1, or 100% of values is a good way to think about it. 100% of my values are under that curve but above the x-axis. It describes the overall pattern of the distribution just like a histogram does, the shape, outlier, center, and spread. If it's symmetric like this, we can use mean and standard deviation and then z-scores, and you can see the corresponding z-scores down here at the bottom. The median of a density curve is the point that would divide it in half. So if I chopped it and I had the equal area on the left and the right, the mean would be like putting a little triangle under there and finding the balance point. Those would be the same for a symmetric curve, both lying at the center. And a mean for a skew distribution would be pulled towards the curve, pulled towards the tail, excuse me. Okay, here's your free response. A teacher gave a test with 10 questions. Here's the mean and standard deviation for the raw score out of 10, and the IQR, and the median. She later found out one question was written correctly, so she added 1 point to everyone's test. She then turned them into percentages by multiplying by 10. I want to know the mean, mu, and the median, standard deviation, and IQR of the distributions after that transformation. So look back at those rules. And then just write one sentence describing how the center, mean and median, how that was changed and why in terms of shape, center, and spread. And then IQR and standard deviation, which one of those transformations or both or neither changed both of those values. So pause now, look over the summary for chapter 2, lesson 1 in your book, look back at the formulas for z-scores and transformations, and then answer the free response.